Welcome back. Now that you've got the basics of annuities figured out, we're going to have a look at our first formula so we can start doing some calculations. And the first one we want to learn is how to calculate the future value of the annuity. So when we're dealing with annuities, the future value is the equivalent value of all of the payments at some future date. And in this case, we define the future value as being right at the end of the last period or right when the last payment takes place. And if we do that, we end up with the formula we've got here. You may notice there's some familiar pieces to it. In here, for example, we've got the formula for compound interest making up the heart of our new formula. And so you can see it's all based upon compound interest. If you can do that, subtract 1, divide by small I, then you have the accumulation factor. Multiply that by your payment and you'll get the future value. Let's go and try one out and see how it looks. Jane plans to save $100 every month until she retires in 35 years. How much will her savings grow to if the account earns 6% compounded monthly? Well, let's start to write down some of the things that we're given here, just like always. Payment is equal to 100 per month. N is the number of periods, and since we're working in months, we'll multiply 35 years by 12 months to get 420 periods, or 420 months. And small I, we do like we've always done. With compound interest, we'll divide it out to get the rate per period, 0.005. And we want to find how much she's going to have in the future, so that's the future value. Here's a formula that I had on the previous slide. Payment times 1 plus I to the power of n minus 1, all divided by I. Now I'm using square brackets for the bigger set of brackets. They don't mean anything different than ordinary brackets, so don't worry about that too much. Let's plug the values in here. We're putting in $100 every month for 420 months. And if we do all the math on that and work it out, we'll see that Jane will end up with $142,471.03. There's our answer. So $100 a month, maybe at the end of every month for 35 years, Jane's going to have $142,000 waiting for her at retirement. That's kind of it for that question, but while we're here, let's just think about something extra. She has $142,000 waiting for her to retirement. How much did she actually put into her account? Well, she put in $100 a month for 420 months. That's $42,000. That's how much she put in. So what's that mean then? Well, she made a lot of interest, didn't she? The interest earned is going to be the difference, isn't it? The 142,471 that we had up above minus the 42,000, which is $100,000 roughly in interest that she earned over the life of her deposits. That's pretty typical when you're dealing with annuities and compound interest over a long period of time. A very large portion of your future value will be due to interest that you've earned on your money, not the actual contributions you've made yourself. That's why retirement planners and financial advisors are often so excited to work with young people to say, look, if we get you started early and you can save for a long enough period of time, interest is really going to be your friend, isn't it? We're going to earn a lot of interest for you. Let's give you one to try out and see how you do with that. Fernando deposits $100 each month into a savings account earning 7.2% compounded monthly. How much will be in the account after 20 years? This one's very similar, shouldn't take you too much work, but let me give you a chance to give it a go and try out the formula. So I'm going to suggest you hit pause right now, work through it, and then when you're ready, hit play again. All right, welcome back. So let's see, we've got a payment of $100 going in every month. The interest rate here is 0.072 divided by 12, which is 0.006 this time, just a little bit better. And he's going to do it for 20 years. There's 12 payments per year, so $240 deposits, and we want to find the future value. Let's plug the numbers into our formula. We do all that, we put it into the formula, and hopefully you came up with something like this: $53,376.23. More than double what he actually put in contributions, even over 20 years. So Fernando will end up with $53,000 total. I hope that one worked out for you. Now, that's kind of it for future value. It's very easy to do if you've got a good base already in compound interest. But there are some extra twists that we see sometimes, and I'm going to show you one of those next, where we take it just one step further. All right, let's have a look at another example. This time I want to deal with a situation where the rate changes on us partway through the term of our annuity. How can we deal with that? Well, Heather's contributed $1,500 at the end of each year for 12 years into a savings account. But partway along, the rate changed from 4.5%, which was in effect for the first 8 years, up to 5.5% for the remaining time. And we want to find out how much was in her account at the end of, not just at the end of her contributions, but 5 years after the last contribution came along. So I'm going to draw a little timeline to help get organized first. So there we go. And here we are at the beginning. And she's going to put in $1,500 a year for the first eight years. I know she's going to keep going all the way up to 12 years, so I'll put that in there as well. But I put 8 in because I know that's when the rate changes. And so what I'm going to do to resolve this, I'm going to break my annuity into 2 parts. I'm going to say, okay, for the first 8 years, that's one annuity. And then for the next amount of time, maybe I'll switch colors here to keep it extra clear, we've got another annuity, don't we? And we want to find the value in our account 5 years after the last contribution, so that's going to be the 17-year mark. That's when I want to find the grand total. So here's how I'm going to approach this. For the first 5 years, we had, our first 8 years, we had a rate of 4.5% per year. And we're going for 8 years. Everything's annual, so it's nice and easy to calculate I and N. And then we had an annuity where the rate was 5.5% for another 4 years. So let's see if I can write some of that down now as a bit of a formula. The first annuity, $1,500 a year at 4.5% per year for 8 years. Looks like that, doesn't it? That would be the future value of that annuity at the 8-year mark. The second annuity is another $1,500 a year, going in at 5.5% for 4 more years. And it looks like that. That would give us a future value of that annuity, wouldn't it? Now, in each case, let's think about where these numbers are. The future value of this guy came in right here. The future value of the one I did in red would be right here. But where's my focal date for this question? It's actually down here, isn't it? That's where I want my answer. So the focal date's at the very end. What I'm going to do now that I have the grand total of each annuity is I'm going to move those annuities forward to the focal date. So in the first case, that's going from 8 years up to 17. And the rate that's in effect at that point is 5.5%, isn't it? Because the rate changed at year 8. So that's going to go forward for 9 years. The second one is also going to get carried forward or keep earning interest essentially for another 5 years. So that's my completed equation, right, for the total for these. And I can work that out. If I do, I get $22,780.69 for the first part, plus the second one came in at $85,12.75. Add those all together to get a grand total of $31,780. $293.44. So that's our grand total for both annuities added together at the 17-year mark. So whenever you have a rate change, just break it into two annuities, calculate the value of each, add them together. But before you add them, remember, just like always, ever since the very beginning of the course, we can't add things until they get to our common date or our focal date. So in this case, we moved our focal date here down to the end, and where we wanted to get the answer, and moved everything there with it, and added them up at that point. Good luck with those. I'll see you again for the next section.